Good morning, everyone, and good afternoon to the people who are listening in from Europe. Welcome to the Danish Wind Power Academy Gearbox webinar. Thanks all for joining. It's going to be good fun. So why are we here? The problem is that many operators are still making critical mistakes and relying on poor maintenance practices that lead to far more failures and downtime than is really allowable. It leads to increased costs, and these are all things that we want to be seeing the industry deal with over the next year or so. We've made great strides over the last few years, but everything we can do to make these turbines more profitable, the better. So in this webinar, we hope that you will gain some essential tips, techniques, and knowledge you can use to improve your understanding and approaches towards gearbox maintenance and ensure the longevity and, critically, the profitability of your assets long term. We will begin the webinar with a short video, followed by a debate of the core concepts between Kenneth Carter, editor of Wind Systems magazine, and Carsten Andersen, CEO and founder of the Danish Wind Power Academy. You will be able to send in your questions at any time using the chat function on the webinar system, so you can let me know if you have any technical issues at any time. Before we begin, I'd just like to ask Carsten just to introduce himself very briefly, why he's here, and what he hopes you will gain from the webinar. Carsten.
Hey, Kay, thanks for inviting. Yeah, first of all, I started in the industry in '89, so I spent 28 out of my 51 years in the wind industry. And the gearboxes have always been a bother for me. I joined the Flender critical exchange we had a few years back, 10, 12 years back. And it keeps coming up to my mind that we're not paying enough attention to the gearbox to be able to, how can you say, get the most efficient lifetime out of it. So I have a high interest in this and in general OM, but specifically on the gearbox. That's really why I would like to have a good dialogue today.
Perfect. Thank you so much, Carsten. And Kenneth, would you be able to introduce yourself as well?
Yes, I am Kenneth Carter, editor of Wind Systems magazine. I've got over 25 years of journalism and media experience, and been in the wind industry for almost 2 years, and I'm learning every day, and I hope to learn even more with this.
Perfect. And thank you to everyone else who's listening in at home. There were over 750 people who signed up for this webinar, and we've got about 150 of you listening live, so that's really quite fantastic, and we're really excited to have you. So as I said, we'll be beginning this webinar with a short video. Unfortunately, this wouldn't be a webinar unless there were some technical problems. So we are unfortunately unable to share our screen with the video on it. So what I'm doing right now is I've sent everyone a message using the chat function on their GoToWebinar dashboard. So in the right-hand side of your screen, you should see a message appear with a link to a YouTube link. If you can click on that link, that will take you to the video that we'll be watching to start the webinar before our discussion later. The whole video takes about 8 minutes to watch, so we'll be back with you in about 8 minutes. Thank you all, and make sure you let me know if you have any technical problems. Cheers.
Well, Karsten, thank you so much for putting that video together. That was fascinating.
It was a little bit of a quickie yesterday, but we actually planned to make a nice video from our Gearbox facility in Belgium where we trained with CF, but the noise in there was impossible. We couldn't make it. So the second best was to pick a wind turbine somewhere near the office and go and take a look at that instead. So we decided that rather late last week, and so it hasn't been without much planning. But I hope it got to the point where people got a little bit of the message also due to the poor noise quality or the poor audio quality.
So that was would you say that was a typical turbine for the point of what we're going to be talking about today?
It's a typical modern multi-megawatt turbine. It's a good example of actually a lot of good efforts put together in trying to really engineer lifetime and actually get to the point of having things lasting 20 years. Not that I can promise we get there, but it's a good example of a modern multi-megawatt turbine. Yeah.
Okay. Well, we have a couple of questions that I want to ask to get the ball rolling. Hopefully, this will spark some discussion amongst the people listening in. we have some polls set up to kind of accompany these questions. So what I'm going to do is start out asking you the question, and we're going to set up the poll for that one. And as the listeners are voting on the poll, I'd like for you to talk about what's going on with that. Does that work for you?
Yeah.
Okay.
Yeah, that's fine.
All right. Well, this question will be for poll 1. And so it is normal asset management efficient enough to save Gearbox lifetime?
No, by far. We are too far away. I would say what we often see in these huge portfolios is that we are remotely operating, and they actually call it remotely operating. I don't think we can operate anything remotely, but we are controlling or we are observing remotely. But most focus goes in the direction of having an asset going all the way up to being a 300 or 400 megawatt wind farm. I find an asset is one unit. And whatever we like it or not means that we will have 200 units or 300 units on a wind farm. And if we keep looking at it from an asset perspective, just of a wind farm of 200 to 300 megawatts, we are paying. We'll be paying out on this. There's no way we can handle each turbine that way. Just looking over an asset being a 200 megawatt wind farm, we have to get down to unit focus. There's no way around that.
Mm-hmm. Okay. Okay. Well, the poll shows that no. Is that in line with what you were saying too?
Yeah, we have a clever audience. That's nice.
All right. Well, let's go to the second question. Would be poll 2, and is it necessary to know the load of individual turbines?
Yeah, because if you want to, I can see the answers here they put in on the wrong question. If you want to be able to evaluate your gearbox lifetime, maybe seen from an inspection perspective, if you look at a load or if you look at a picture indicating a certain wear, how can you determine lifetime if you don't know how loaded your machine is? Mm-hmm. It's like your red cooler lamp in your car is lighting up, and it will probably make a difference if you're going 50 miles an hour or if you're going 150 miles an hour. So we have to care. Can you find the right questions for this or the right answers for this question? Because what I would like to ask if people actually know the CP factor of the individual turbines. But you're giving me something about temperature.
Okay, so I launched the second one as you said before. So give me a second. Let me close this one. Everyone's been answering it anyway. So the only other 2 questions I have for you are: can you read and understand the results of your oil samples, and when do you conduct the first endoscopic inspection? So I only have 4 polls for you.
Okay, so maybe there wasn't one for that one.
Okay.
It's okay. No, but back to the discussion about the CP factor. The CP factor is a simple expression of percentage of full load hours, and there's no way we can evaluate remaining lifetime in a gearbox if we don't know the operation conditions the gearbox or the turbine is located in and placed in. I have customers that don't even know if they have an IEC Class 1 machine or Class 2 machine. And if they go to inspect it, how can they say I have 2 weeks back in on my high-speed shaft, or do I have 2 months, or do I have 2 years back on it in lifetime? They have no chance. So the CP factor is an extremely important little simple number that we need to keep behind our ears in each individual unit to be able to determine lifetime, for sure. Well, now this polls here, I think this one is related to something with gear oil temperature, but
yeah, we'll get. I think that goes with the third question we were going to ask.
Yeah. Okay. Well, what was the third one?
Okay. The third question is: what is the correct operation temperature of gear oil?
Yeah, it's really one I would like to understand from the audience. Kay, if you throw up the same question again, no, the previous one, and can they poll it again? Can they vote it again?
The CP factor one.
Yeah, the one with the wrong headline, but it had all the degrees on, which is important.
I just do what I'm told, Carsten.
Okay, you can just run it once. Okay, let me let me fill in on this one. If you speak to an oil guy, which is happy about his gear oil and the guy that promised you a certain number of years of lifetime on his synthetic gear oil, he would say that the nominal operation temperature should be somewhere between 63 and 65 degrees. That's really where he finds that will be perfect. And he will probably continue, because after this he will take a deep breath and then he will say, yes, but if you get up to 10 degrees above nominal operation temperature, you will halve the lifetime of your gearbox oil. So if you'll be operating at 75, or which I've seen before, somebody doing almost 80, you will actually reduce lifetime on your gear oil with up to 50%. So it's really important that we keep that gear oil temperature down, which means we need an extreme high focus on the complete cooling system around it. Beside that, of course, it's also not only about cooling, it's about cleanness and particles and stuff. So it's a good indication is if you're running your gearbox with a higher temperature than 65 plus minus a few degrees, going up to 70, 75 or even more, then you shouldn't be sleeping very well at night, for sure. That should make you worry, and you have a good reason for that. Okay.
Okay.
I think we can get back on this on the open discussion afterwards.
Yes.
Anybody have other ideas?
All right. Well, let's get to that fourth question. How is oil sampling a key indicator for gearbox conditioning?
That's if you do it the right way.
Did we have a poll for that one? I can't remember if we had one for that one or not.
Give me 2 seconds.
It is probably one of your most important and cheapest key indicators you can do if you do it correctly and if you do it under the right conditions. Kerr is still looking in his archive. But yes, oil sampling is very well important. I'm not very fond about the idea that we are bringing in the how can you say, the offshore service checklist to onshore, where we only doing service once a year. I like the old days where we took 2 oil samples a year, because that really helps us to keep focus. An oil sample is a cheap and a very simple way to keep a good insight in your gearbox condition and in your gearbox situation. But then again, like I said, we need to take it the right way. I know oil labs that are telling me, I have one in Denmark actually, that are telling me that less than 10% of the oil samples they are getting are representative. They're either too old, they're taken under wrong conditions, they're taken in dirty bottles, or they're taken with dirty hoses, which means that I simply don't see attention enough among the owners and operators to take a valuable and correct oil sample. It's so cheap to do a nice piece of work, but it's so easy to waste 100, 150 EU oil sampling, including the time, if we don't do it correctly. So it's the oil sample is extremely important, and it's very straight up and down to use if it's taken the right way and analyzed the right way.
Well, it's encouraging from the poll that we got 57% can understand the results of their oil sample, so that sounds like a good direction.
Yeah. That's like I told you before, we seem to have a clever audience, but I still think there's a lot of things to be done here, because oil sampling is often done by different people under different conditions, under different concept and different wind turbines, and we really need a very, very refined method that is always the same under the same conditions. We can't take oil samples and store them in the site office for 3 months before we set them in. We have to take them while the gear oil is cold or warm and representing operation conditions. There's many things that have to be determined as a must way of doing it. I know from my early days when we had many turbines, many different turbine types in maintenance, and we had many different people doing it, sometimes in different countries, that our oil sampling result wasn't that efficient a history as they can actually get. If you do it right in the right way, you can have a very efficient, a very, very detailed history of development of your situation in your gearbox. But yes, we are on the right way, but I'm pretty sure we can still do much better.
Is the technology for for understanding these oil samples changing? Is it getting more advanced or more intuitive to be able to do that?
There's online stuff. I know CCN is offering online particle counting, where you have a little indication of what could be going in the wrong direction. But when it comes to the oil quality and the oil type, we're pretty much looking for the same things. When it comes from the dirt inside the gearbox, whatever it's races or bearings or gear wheels or whatever, we also look for the same thing. So it's not really that high tech. The main thing is that we have a good neutral professional oil lab that is actually expressing exactly what we need to know, and there are plenty of them out there today.
So you're basically saying it's more training than technology that allows you to understand the oil sample.
Yeah. If you don't take the right oil sample, you waste all the people's time in the whole circle of spending hours with analyzing and spending hours with sending them back to the customer, them reading it and them thinking and them talking to people what they see. Oil sampling is only bringing value if it's done correctly. And if it is done, then it's really valuable, on the other hand.
Okay. Well, how important is it to inspect your gearbox, and how often should you do it? And hopefully we can get some audio.
Yeah, that's a good one. I'm often smiling when we're doing end of warranty training once in a while. We teach people how to inspect their turbines for end of warranty, and they would often say, this is the first time we're inspecting the gearbox. If you want to evaluate lifetime of your gearbox, you need to have a reference inspection when the gearbox was new, basically only a few weeks after put into operation. There's no way you can look back from year 4.5 before end of warranty and determine how long time it took your damage to develop, especially if you don't even know the yield and the load of your machine, if you don't have a picture documenting that actually this was nice, perfectly, 110% okay back at TOC when I took the machine into operation. If you started year 4.5 to do the first inspection, I would say very simply you are orbiting somewhere around the planet, and you have no idea how you will be able to see a damage. Probably you will find something, but you have no foundation to be able to evaluate if this happened 2 months, 3 months, or if it's something sticking back to a transportation damage, maybe standstill marks or whatever, because you don't have any reference. Mm-hmm. You simply need to inspect your gearbox already almost at day one, but at least a few months after you took it into operation. And even if you take a lot of very nice pictures and you create a wonderful report, everything looking perfect, you will need that reference later when you have to come back if you realize you have challenges going on. So there is no way around that. So I can only say, get out there year 1 and do the inspection, and then do it again year 2. If you find that everything is perfect and keep staying focused, then maybe you could do it every second year. As well as we also take pictures of good things. Many people are only documenting bad things. If we don't document the things in the conditions they are when they are perfect, again, we don't have the benchmark for later on if we have to go back and say, when was it okay? How fast have it been developing? So it's really important. The inspections is also, like the oil sampling, a key part.
How do you manage those inspections when you're talking about wind farms of 100, 200 turbines?
Yeah, that's probably why some people say I only need to inspect 10%, and I got a good picture of the conditions of my gearboxes at my wind farm. It's not easy. It's something that should be done. If your machine is shut down anyway due to service and maintenance, I would recommend that one guy can do the inspection. Usually you will have to send out 2 guys to do unplanned inspections or unscheduled inspections due to safety. But if you're there anyway to do a scheduled maintenance, you have maybe another 2 or 3 guys in the machine. So now you can use only one guy to do inspections. And that would be a good period. That would be a good time to do it, because most often that's where the machine is shut down. That's where the wind is low. That's where you don't lose too much AAP by stopping, so that could be a good thing. But it takes manpower, and I really think it's recommendable.
Okay. The big deal these days is talking about predictive maintenance. How does that factor in to the inspections of these gearboxes?
That's a must-do. We're analyzing gigabytes of turbine data every time we set up a new training, a platform-specific training, and I can see that many of the errors, even if they don't even look specifically as impacting on the gearbox, but the way we stop the machine, or the way the error indicates an overload or an asymmetric wind load, whatever, it will impact on the gearbox. So we have to read and understand, like I told in the beginning, the yield of the machine to be able to do something different. If I take a look at where we spent the time on our checklists, and I compare that where we get the time, the downtime from the machines, we can do significantly better. We put a lot of effort, I know that, in mechanical checks, alignment, ball torquing, and oil sampling and different stuff. But very often we have downtime pointing in a complete different direction. So a good suggestion is that maybe try to look at your errors and try to look at the work you are doing and your checklist, and then see if you could add any kind of smartness to your checklist, any kind of preventive or predictive maintenance. And I'm sure you will come up with several handful of ideas that will help you to also extend lifetime on your gearbox.
So what you're saying, if I understand you correctly, that predictive maintenance is a good start, but it's not a substitute for a good old-fashioned getting up there and checking it yourself.
No, I think the easiest way I can probably explain it, being an old technician, is that we need brains in the machines. I know we have all the CMS systems, I know we have all the alarms, we have vibration monitoring control, they can send us all kinds of red and green and yellow lights, but they will usually do when the failure started. And I would like to have the discussion going on around how can we avoid the failure starting in the first place. And that means we need to analyze, we need to think, and we need to act on it before we are getting a feedback on our vibration system. Thank God we can get the feedback when it's too late, but I would much rather have we don't even get to that point.
Right.
So it is, and again, that means since the yield is different on the machine, since the CP factor is different, we cannot run a rigid checklist where you can have a wind farm in some locations of the world where you can have an onshore wind farm with a CP factor between 25 and 55 because it's close to the seashore. There we cannot run the same checklist. It's not, I know it's convenient and it's easier to control manpower and it's more, how can you say, efficient, but it's actually not the best for the machine.
Right. Okay. When we talked last week, you brought up a really interesting analogy using cars and the lifetime of cars. Could you kind of explain that to the audience? Because I found it really interesting, and it really kind of brings it home as a really, really good analogy as to how you should be also using that same methods basically for the turbine inspections.
Yeah, there's actually two I heard earlier. One is that the one I also mentioned in the video, by 8,000 and some 100 hours a year on a wind turbine operation, we have one service. If we drive a car for 8,000 some 100 hours, we'll probably drive it for 10 years. And under these 10 years, we will also probably have 10 or more services going on, at least once every year, depending on how the scale is for maintenance. So it's quite saying that we run a car for 10 years with 8,000 hours and we run a gearbox for 1 year with 8,000 hours. The next thing is, if you look at it from the gearbox side, and we are busy sometimes in pointing our fingers at the gearbox and the bearing manufacturers, they don't produce special gearboxes for special environments. They will make a 3 megawatt gearbox, period. And that gearbox will be made and satisfying an engineering envelope, whereafter an OEM will go to his shelf in his warehouse and pick up the gearbox, and he can put it into an IC class 1, 2, or 3 machine, or subtropical or Arctic machine. If you put it the other way around, you can imagine you can create some type of a 5-speed or 6-speed gearbox for a car. It will be made for one in one engineering envelope, and at the same time you can put that gearbox into a Formula 1 car or your grandma's old Ford Focus. And you can decide how many years that gearbox will probably live in each one of these two cars. But it's the same we see the manufacturers are doing, the gearbox manufacturers. They don't produce specific gearboxes for specific needs, and that means that's why I keep putting it back to the fact we need to know the load of the machine to be able to determine if our gearbox lifetime is fair or not fair, or how long it will be. So we are, and again, like I also said, the once-a-year service plan is not really my favorite, but I can see we need it to reduce pricing and cost and OPEX, especially offshore. But again, it's not a perfect solution for the way, at least not the way we operate the gearboxes.
Okay.
So yeah, but what do you think? Should we open the discussion?
Yes, I was about to say, let's go ahead and get to some questions if that's okay with you. Looks like we're getting some already. So let's start out with this one. One says, Karsten, it wasn't clear to me whether a higher CF helps deteriorate the wind turbine as a whole, including the gearbox itself. Could you please elaborate?
Once again, I need the beginning of the question once again.
Sure. So it wasn't clear for me whether a higher CF helps deteriorate the wind turbine as a whole, including the gearbox itself. Could you please elaborate?
Okay, I guess he means the CT, the higher CT factor. For sure, it's not only the gearbox. I can now we have a focus on the gearbox, but the load is high on everything. The load is high, and especially also depending on the wind classes. It's high also on the yaw system. It's high on everything, on the coupling and how much turbulence we have. So no, the gearbox is not the only fellow suffering here, but the gearbox is placed in the middle between power regulation, nominal power regulation on the pitch system, and the converter regulation in the other end. And whatever we do where we are failing, we seem to hammer that little blue thing right in the middle all the time. So it is taking a certain yield, especially when we fail to operate correctly, and especially if we fail to maintain it correctly. So no, it's not only the gearbox. We will have a higher yield on the whole machine. And that's again the reason why the CP factor is important to know on each unit, especially because it's not only the gearbox that we are loading.
Okay, well, this kind of dovetails in this question because someone would ask, please define the CP factor. How do we obtain it for each turbine?
The CP factor is now I don't want to sit here and mention the formula, but the CP factor is basically the percentage of full load hours you have. You can compare it with how many hours a year you're driving with your accelerator pedal pushed to the metal in the bottom of your car. How many hours are you driving full speed with everything you can pull out of that poor Ford F-150 you had? It's the percentage of full load hours, and that gives you a good indication of the, how can you say, the average load over the year. And that can, I have a formula, but I don't have it with me right here, but you can Google that and it will tell you exactly how you calculate full load hours. It's not high academical calculations.
Okay. Is there an international standard on how to take oil samples?
Yes, there is. I will not say an international standard because there's many types of bottles and connections and hoses on so on, but there's a few simple things, a handful of few things to be said is that you need to take an oil sample under the conditions where the oil is representative. That means right after you stop the machine, depending on how much oil you have and how warm it is, but probably not more than 20 minutes after you stopped it. You want the oil sample to be representative. You need to take it in a clean bottle, and even if you think the bottle is clean, you flush it, and you flush it, and you flush it once again, and then you fill it. And of course the hose or the fittings you will be applying to the system have to be clean and flushed. So there's depending a little bit on what kind of platform we are talking, there can be different ways of where you take it and how you take it. Most often you would find that if this is described, I know most OEMs on their own platform have a pretty detailed and very specific procedure described of how you will do it in either a Vestas or a Siemens or a Gamesa turbine, and that's the one you have to go for. At least that's what I find a good solution or a good suggestion.
Mm-hmm. Okay. We have a fascinating question here, I think. What is more important in maintaining turbine lifetime? Is it a higher CP with lower vibration or lower CP with higher vibration?
I would love to have a high CP with no vibrations and no turbulence. 10 years ago, when we thought we could run away for offshore and everything would be perfect and we will have no problems anymore the rest of our life, we realized that even in offshore we have turbulence. If the load is steady and high, that would be wonderful. The problem is it's not. So if the higher CP comes with an 80% turbulence on wind or whatever, then I'm not very happy about the higher CP. On the other hand, we can also see if we're going inwards in different countries, like for instance Germany with a CP factor of 10 to 15, we can see things are living longer, but we can also see a relatively poor income on annual energy production. So high load is actually nice if it's clean and if the roughness in the terrain doesn't give you too much turbulence. Then I would be happy about it, but it's very rarely the case.
Okay. We did talk about predictive maintenance. We got a question kind of talking about that. Is there technology out there to help determine gearbox failures such as sensors to read oil sample? If so, do you see this as a valuable tool?
I think it's a valuable tool. It's not black or white. It's not only that and nothing else. A few months ago, I visited the exhibition in Husum, on Hamburg, Husum I think it was, and some guy came up with the idea, or there was actually several of them, but they just wanted to put a GoPro on the head of some hardly even English-speaking fellow with a lot of batteries in his pocket, and then he could just climb the machine and they could remotely sit and monitor everything and check everything. I think wind turbine operation doesn't get better than the last guy leaving the machine and locking the door. We need brains out there. I love all the systems. I love the CMS. I love everything, but nothing without. It's really, it's false. How can you say it's false trust to sit there and think just because my system will give me a red heads up on a red diode, then I'm happy in time. I like them all, but they have to be supported by human brains and a little bit of ownership for operation.
Okay. Also on that topic, this question is, as a current student in the industry, would the gearbox be included in preventative maintenance?
I think actually what we see with many of our customers, the owners and operators that are self-performing, they are doing that to a much higher degree today than we saw just 10, 15 years ago. So I think it's moving in a direction that gearboxes are expensive and worth taking care of. But we also see other challenges, not only on the gearboxes. We cannot keep all that, give all that blue thing all our attention. We have challenges going on in similar ways on blades and different other things. But I see that we have a higher focus among our self-performers, maybe due to previous pain and their experiences, thinking that they really have to do something different. So we have a much higher degree of preventive and predictive maintenance today than we had just years ago.
Okay. Next question. We see a variance of oil viscosity index, and your video mentions oil fill. Do you see VI being important, especially in different climates?
If we are operating correctly, if we can keep the oil temperature nominal, we can run the same gearbox from an Arctic climate to a subtropical climate, but only if we can keep the oil viscosity with respect to the operation temperature it should have. If we fail in that, yes, then we will probably have to think about other oil viscosities. For instance, the XMP 320, which most people are using, or to a very high degree, they will cover that wind turbine from an Arctic to a subtropical solution, but only if we can keep it in the correct viscosity due to the correct temperature. But if we fail in that, yes, then we would have to think about other types of viscosities. But it's not that easy to change the oil. If you are looking at many of the cooling and lubrication systems today, they're calibrated for a certain viscosity and of course under a certain temperature. So you cannot just receive a nice cheap quote from somebody that have a very great oil and then change your oil without having the risk that this interfere with your cooling and with your lubrication. So it's something that is sensitive, and now I'm not an oil engineer at all, but I have seen damages that can be lead back to the fact that oil was changed, gearboxes were not flushed correctly, and oil was not operated correctly on the given temperatures.
Okay. Okay. Gearbox life is calculated using various IEC win classes to ensure they can be used in the various IEC classes. Can you explain in more detail why a gearbox should not work well in a high wind speed versus low wind speed?
Yeah, well, it goes a little bit back to the turbulence, the unpredictable power we're adding into it. First of all, I want to say one thing. We're looking at a gearbox, and we call it a gearbox, but what we really have here is a multiplier. It has nothing to do with the gearbox. We take the high, in this case, like in the Vestas machine I was in, we take a 4 million Newton meter input shaft on a low-speed shaft, and we turn it into a 4,500 horsepower high-speeding output shaft. Any normal guy that would build a gearbox, he would like to do it the opposite way around. He would put in the high loads on the high-speed shaft and take the load out of the working, how can you say, main shaft in the gearbox. And that just means that if we cannot control the input by winds changing, going up and down, we're struggling much more to control load in the gearbox than we would do if we used the gearbox, how can I say, the right way. Now we're using it the opposite way, and that's really part of what we sometimes forget. You can imagine that how you would turn your yaw gears if you with a big hand would grab you on the sill and just turn it 90 degrees in 1 second. Can you imagine how your yaw gears would be spinning at that point? And it's a little bit this we're doing. It's kind of like the same thing we're doing when we're adding torque into our gearbox. So we have a lot of theoretical lifetime calculations. I think they would last nice if we could plug in the wind and say, now I want a 3 megawatt wind input, nothing more, nothing less. But unfortunately, that's not the case. And then we are adding poor maintenance, late maintenance, wrong maintenance, missing maintenance, or we are adding overloads by wind shear and all this kind of stuff on top of that. So your theoretical calculations for your gearbox lifetime is somewhat already disappearing down the drain. There's no way we can relate to that, or we should relate to that. I guess most people have experienced that already.
Okay. What about design? Some of the high-speed shafts have very different bearing assembly that may behave very differently under transients and affect the lifetime. Do you have some clues about which type of assembly should be avoided?
Oh, this is difficult. It really depends on the gearbox manufacturer. Some would like to have 3 bearings supported, or the third bearing being a roller bearing supporting it. Some would have tapered bearings, pre-tension tapered bearings. I think I see a tendency to having the pre-tension tapered bearings going out today, which means that your high speed, if let's say you take a high speed shaft package and you want to change that in the field, it will show up probably already completely assembled and pre-tensioned. This is very often what I see today, which also means that you cannot do much work in a nacelle under these conditions like we could on the old days on smaller wind turbines. We will also sometimes see that the tolerances in the housing is documented. That means that the day you will have to do a high-speed exchange on one of your 3 megawatt gearboxes, you probably have to call back and ask for the tolerances, because even if we're going somewhere between 1 and 5 micron in machining tolerances, every little setup of every little high-speed shaft is unique, and that means you cannot just ask for an assembled high-speed shaft and add it in any of your gearboxes at site. They will belong to that specific place, that specific location, and that is documented. That's what we see with, at least what I see with the manufacturers that I'm visiting today. So it's much more sensitive. Like I also told you that machines are getting bigger, the gearboxes are getting bigger, but the tolerances are getting smaller, and they get much more narrow and much more precise than we used to. Mm-hmm. So the future of gearbox repairs will change when it comes to our idea about repairing very much in the field.
Well, if we use gearboxes the wrong way nowadays, wouldn't DD turbines be an answer?
I wouldn't say we use them the wrong ways. I think we could learn a little and prepare ourselves a little bit, dress up for some better operation. DD is nice, but I think we need some track record before we get to the point of if you're a portfolio-driven utility and your whole business case is powering down nuclear plants and powering up renewables, and you want to go for something that maybe you know will give you a little bit of pain, but at least you know the pain and you can control the pain. And for that you need reliability and you need track record. And that's where I see that we're getting there slowly, and I would be looking forward to seeing especially European direct drive machines taking a little bit up the competition with other guys on the market. But I think it takes us a little time to get there. There's some challenges both on the electrical side, but also on the mechanical side on the direct drives. I think semi-drive drives or semi-drive will be a solution. Instead of 1500 RPM, we will go to 500, 700 RPM. We will have a different setup gearbox in a different physical, a difficult physical setup drivetrain, and so we will get a more like a hybrid version between the direct drives and the now traditional drivetrains, where the generators and gearboxes and everything is isolated from each other.
That's fascinating. Do you have a relationship between a reduction in vibration and an increase in gearbox lifetime?
Yeah, we need to know a little about the vibration and what is happening. But if the load is outside the engineering envelope, if the vibration depends on where it's coming from, if it's turbulence and so on, yes, we are loading the machine, and that's why we should do the inspections. That's why we should check the gear wheels, and we should check the bearings, and we should check everything on a not on a daily matter, but at least on a yearly matter, to be sure we keep track of it. Anything unnatural I'm not happy with when it comes to the gearbox, and we have a lot of unnatural yields and loads coming in.
Okay. This question deals with CP, and I would, if you don't mind, going into a little bit more detail about what CP is for some of our listeners as you answer the question. But the question is: low CP would increase life but reduce income. High CP would reduce life but increase income. What percentage is the sweet spot?
Oh, I've seen offshore machines actually working with a 45, 55 CP factor and actually surviving well, because we have less turbulence than we have on an onshore condition. I also see a lot smaller onshore machines with a lower CP factor, where the gearbox lifetime is somewhere between 3 and 5 years, simply because only of the turbulence, even when they produce less AAP. So there is no golden rule. That's why it's so important to understand every time you get your error from turbine, something that you already in your mind have: what have been my last year's CP, what have been my last year's load on this machine compared to the other machines. And this is not on a site basis, this is on a pad basis on each machine. You will have different CP factors at site, not offshore, probably not, but onshore you can risk having different CP factors on 20 turbines in a mountain, somewhere in God knows where. And there is no, I would say that like I told before, I'm happy with the high CP factor and the high AAP if I don't get the turbulence, and hereby don't get all the unplanned yield. But I can also destroy my gearbox with a CP factor of 30 or 24 if I got a lot of turbulence. So I cannot give you a recommendation how you speed up your machine to a certain AAP a year and then you leave it there and then it lasts for 20 years. That's not really that's not really the case.
Okay. Why not design gearboxes to withstand higher loads than using the same gearbox for all different wind classes?
Hey, we all know what happens to the cost of wind turbines right now, don't we? We have to compete on the market with many things, and we have been pushing the pricing down on wind turbines for the later years in the range of 20%, and everybody behind that probably need to, unless they're very, very friendly with the OEM, also have to push their costs down on developing new technologies and maintaining, how can you say, gearbox lifetime. So we can engineer almost the perfect gearbox, but we can't get it paid off. So we don't have that. We don't have that, how can you say, possibility. We need to engineer for the engineering envelope, and we need to put the machine in and put the gearbox in that fits the load. The question is that we have to adapt our service and our maintenance and our operation to the load we see in the machine, and they're all different, and that's where it gets difficult. We cannot afford to buy the gearbox that lasts 20 years, but we can maintain it nicely, and we can operate it nicely and make it get a good way up there. But I think that the perfect gearbox is not really out there. It would be if we had control over the input, but since we don't have that, there is no really perfect solution.
Okay. Well, we have less than 5 minutes left, so we have time for one more question, and this might be a loaded one, but be a way to end it pretty well. When will gearbox damages disappear and gearboxes become reliable?
I think we have reliability in our gearboxes. I got to say that I'm back with the three fingers. I can point at gearbox manufacturers and say they're sloppy and lazy and they don't produce nice gearboxes, but I'll have three fingers pointing back at myself and say, why do I operate it with 85 degrees? Why don't I do the inspections? Why don't I take correct oil samples? Why do I have dirt in my oil? Why do I have moisture in my oil? I had a guy from an offshore site last week, the previous week, on a gearbox training in Lommel, that was running a big offshore wind farm without silica gel filters, breathing filters on his gearbox. He didn't have nothing but a paper filter, which means you're breathing moisturized air in and out his gearbox. This is I wouldn't say it's suicide, but it's somehow in the direction of being suicidal when it comes to your gearbox lifetime. And if we experience this in 2017, we can do a hell of a lot of a better job keeping our gearbox lifetime up if we just add to the fact that and look naturally at the point that the input is not reliable. The gearbox is actually reliable, but the way we are treating it and the way the wind is operating it is not very reliable, not predictable. So I would say that if people would pay attention to the loads and the yield of the machine, they could easily extend lifetime on their own machine somewhere between 15 and 25%, just by not even adding extra cost, not even buying hardware, not even changing gear oil better, but just keeping up oil quality and keeping up, how can you say, good gearbox maintenance. So by going to the machine and actually do the right stuff, they could improve. I see that when we analyze the data on our wind turbines, when we do training, somewhere between 50 and 60% of the downtime we have is related to people not doing things what they should do when they do maintenance, or maybe because they are struggling with other parts, or maybe they're struggling with other problems. But why should I accept a gear oil level low alarm 3 months after maintenance? The answer was to this specific one. I talked to this guy and he said, yes, but the intermediate shaft is sweating a lot if I keep the gear oil up to the desired level. And say, okay, yeah, then you rather want to not clean under your gearbox, and then you risk losing maybe some of your components in the gearbox because you don't keep the oil level up. We have foaming going on in our gear oil. We have the dirt. We talked about that. We have many things going on in our gear oil that is destroying the very, very high needed gear oil quality we need under these operation conditions. And these fingers are only pointing back at ourselves. I will not point at any gearbox manufacturer, any OEM or anything. I would simply point at the people operating, saying that, okay, you asked for it. You have 85, you have 80 degrees hot gear oil, your gear oil is foaming, you're losing 3 to 5 centimeters of oil level. Your oil sampling haven't been good for the last 3 years if you haven't done any at all. And then don't blame it on the gearbox manufacturers. Not today. 10 years ago we could blame a lot on bearing guys and gearbox manufacturers, but today it's in general, I would say in general we have great wind turbines for sure, but we could do a whole lot better operating them and maintaining them.
Oh, that's awesome. Well, thank you so much. That I think that we've run out of time pretty much. but you've given some great answers and some great questions, and thank you all out there for listening.
Thank you. Thank you for having me.
And thank you, Kenneth, for keeping Carsten on his toes there with all the questions. So, hello everyone, this is Kerr here from New Energy Update. Just to wrap up the webinar, I just wanted to say a big thank you to everyone involved, Wind Systems Magazine and the Danish Wind Power Academy for helping us make this webinar a huge success. We had, as I say, we had more than 750 people sign up. We had 160 of you listening in live today, and we had so many questions coming in that I didn't know what to do with them. So I'll make sure that they all get sent to Carsten. And he and his team can try and resolve as many of those questions as possible. But I think what's really clear from the discussion today is that the long-term value of wind investments could be crippled for a continued lack of understanding on everything within wind operations and a lack of insight available in the industry to direct you to be able to successfully optimize the performance of your turbines across their entire life cycle. So this is why more than 600 of the industry's most forward-thinking utilities, IPPs, developers, OEMs, and innovators all gather next spring for the 10th annual Wind Operations Dallas 2018. Because they're really after the key insight they need to boost profits through successful operational maintenance and asset management by reducing their LCOE, by increasing their AEP, and driving continued revenue growth. Major stakeholders nationwide are already confirmed. If you do want any more information at all, there's some information on your screen right now, or search Wind Dallas, or just download the free webinar handout about the conference in order to find out more. I really hope you and your teams can make it, so do get in touch with me directly if you have any questions. But from us at the webinar here, thank you all so much for your time today. It's been an absolute pleasure. Thank you for bearing with us with the technical difficulties in the video. You've all been fantastic, and have a nice day. Thank you.
Thank you all. Thank you. Bye-bye.